All right, so today we are talking about ratios, rates, and unit rates. We talked about ratios yesterday. A ratio is anything that is comparing two values using division. And so ratios and rates are very similar. The difference is rates, so we've talked about ratios. Rates are when things have different units. So a rate is comparing values with different units by division. So any time you're comparing with different units, then that is a rate, not a ratio. So this would be something like I drove, that's not right. I drove 90 miles in 3 hours. So miles per hour, that would be a rate. Or how many pounds of fruit can I get for $1 at the grocery store? That would be a rate. Or I don't know. There's all sorts. How you can go with. I can buy a 16-ounce box of cereal for $5.49. So ounces and money, different rates. You can identify how much does the box cost per ounce. So we use rates to figure out how much things change. And then within rates, most of the time we see unit rates. And unit rates are rates where the second value is 1. So it's a rate where the second value is 1. So to get from a rate to a unit rate, you want to divide the rate by whatever it takes to get the second value to be 1. So you would divide this by 3 to get 1. You would divide this by 3 to get 30. So this is 30 miles in 1 hour. This would be 30 miles per hour. Okay, so that is one way you might see that. If you were to say, all right, I can get, if I can go to the store and I can buy, I spend $6 and I get 12 apples. I would divide this by 6, divide this by 6. I would get 2 apples for $1. And so I could say I get 2 apples per dollar. So that's how I know what my unit rate would be. So when we do things, anything involving rates and unit rates, you always want to get your rate to be a unit rate if you can. It just makes it easier to understand and deal with it. So one way we see this is we go, all right, I go to the store and I see 2 containers of peanut butter. Okay, let's just say I have 2 containers of peanut butter. There's a 15-ounce jar, and that is $2.19. And there's a 20-ounce jar, and that is $2.78. Which is the better deal? Where am I actually getting more peanut butter for less money? Is it better to get the 15-ounce jar, or is it better to get the 20-ounce jar? And so to solve this, we want to find the dollars per ounce. So dollars per ounce means I want to put the dollars on top. So this first one, I'm going to do 219 over 15. Dollars on top, ounces on bottom. Over here, I'm going to do the same thing. 278 over 20. Dollars on top, ounces on bottom. When I have this right here, see how it says dollars per ounce? The first thing, just like ratios, the first thing goes on top, second thing is going to go on bottom. Okay, this per is a way to say rates and unit rates, and so it's helpful to know first thing goes on top, second thing goes on bottom. All right. And then we solve this. We go, all right, for this, I need to divide by 15 to get 1. Divide by 15 up here. I do 2.19 divided by 15. And that is something along the lines of 15 cents an ounce. So this would be 15 cents per ounce. See, every ounce is about 15 cents. Here, I'm going to do the same thing with 20. Divide by 20. Divide by 20. I'm going to do 2.78 divided by 20 to get me right about 14 cents per ounce. So this deal here is better. It's cheaper to do every ounce is 14 cents, or if every ounce is 15 cents, it's better to do these 20-ounce bottles than the 15-ounce bottles. Okay, so that's why we use unit rates. Unit rates we use to solve for knowing what better deals are, knowing how fast we go, knowing what our miles per gallon are. But it's always good to remember it's going to be unit per unit. Unit 1 goes on top. Unit 2 goes on bottom. Okay? Unit 1 on top, unit 2 on bottom. Find me the unit rate of let's say I am going 525 miles, and it is taking me let's say 10 hours. What is my speed in miles per hour? All right, we'll talk about this some more tomorrow. Good luck.